Today's lesson is over sections 1.3 and 1.4, and we're going to be looking at histograms and box plots. So we're going to look at how they display the data and what we can learn from these different displays. So when we collect data, we take the data and we can turn it into what's known as a distribution. And a distribution is a function whose values are the frequencies, relative frequencies, or probabilities of mutually exclusive or non-overlapping events. We're going to get more into the probability of mutually exclusive events later on in the semester, but you need to know that that's something that could be shown in a distribution. So graphing distributions allows us to see what is happening with the data that we might not notice if it was in a table. So one type of graph that we're going to look at today is a histogram, and that's a special type of bar graph that breaks the range of the numerical variable into non-overlapping intervals of equal width, and those are called bins. And so there's two types of histograms. There's frequency histograms, which display the number of values in each interval, and then there's relative frequency histograms. Remember, the relative frequency is the percent of the data that falls within either a value or a range. In the case of a histogram, it's within a range, and so it displays the percent of the values that fall into each interval. So when we make our histograms, it's important to make sure that our bars are of equal width, or our bins are of equal width. So if we look at our bins down here, you notice that they're going by fives. Okay, this first bar is 0 is less than or equal to x, which is less than 5. So 5, the value of 5 is not contained inside this first bin here. It's actually in this second bin, which is 5 is less than or equal to x, which is less than 10. So 5 is in here, not in here. 10 is in here, not here, and so on and so forth. So it's really, really, really important that you keep that in mind, that we don't have two equals here, because if we did, then where would we put a certain value? Okay, and so no value can occur in more than one bin. So let's look at our examples. Here we've got two histograms. We've got a frequency histogram. We have a relative frequency histogram. If you notice, they look identical. The only thing that's different are the numbers going up the sides. The first question here asks us about how many states have 5 to 14 representatives. So we're looking at this bar and this bar right here, because the edge of this one, the 15, goes into this fourth bar here. So we're going to have to estimate. I would say that this one right here has about 17, and I would say that one has 5. So that's going to be 5 plus 17, which is 22 states. So then it says, what percent of states have 15 or more representatives? So now, instead of looking at those two bars, we're looking at this one, that one, and that one. Okay, or we could look at this first bar and say, okay, there's 20 here, there's 22 here, so that means 44 states are discounted, or we're not looking at those. So if 44 states aren't being included, that means out of 50, that would be 6. And so we have 6 over 50, which is 12%. So the last question asks us, what bin does the median number of representatives fall among the 50 states? So we're looking for the 25th and 26th terms. Because we have an even number, we're going to have 25 on one side, 25 on the other side. So we've got 20 here, which means 25 and 26 fall in here because there's 17. And so it falls in the 5 to 9 representatives. Because it doesn't include 10, because remember 10 is included in the next bin. So let's look at how we draw a histogram. There are some certain steps that we need to follow. So the first step says to organize our data into non-overlapping intervals of equal widths. So just like we were looking at with the last one, we went 0, it's equal to 0 but not equal to 5, equal to 5 but not equal to 10, so we were going up by the same amount every time. So generally you want 5 to 10 intervals. 5 if you don't have a wide spread of data, 10 if it's more. If you have too few, you won't be able to tell what's going on with the data, and if you have too many, it'll be hard to tell what's going on with the data as well because all the bars will be really small, or all the bins. So then we want to count the number of observations that will go in each bin and record the frequency and or the relative frequency, and then draw our graph so that the horizontal axis gives the bin width and the vertical axis gives the frequency or the relative frequency. And then draw our bars so that they are touching. Okay, so unlike a bar graph where the bars are individual and there's space between them, the only way that we have space between our bins on our histogram is if there's an empty bin. So it is okay for one of the intervals to be equal to 0, just like we saw here on our histogram here. We've got an empty bin here, and we actually have, let's see, 1, 2, 3 bins here that are empty. So when we look at a histogram, we want to be able to say something about it. And so one of the things that we could be asked about is the shape. And so 2 words that we use when we talk about the shape of a histogram are skewed and symmetric. So skewed, meaning it's not symmetric, they're clustered or taper off in one direction. So there's a whole bunch of data on one end and then not a lot on another end. Or if it's symmetric, you know, it's kind of small on the ends and comes to a point in the middle. And so here are some pictures of what a skewed or symmetric graph might look like. So if you can imagine bins underneath here being drawn. So if the bins are clustered to on the right side, it's considered to be negatively skewed or skewed to the left. And then this area is called the tail. So the tail is to the left. Wherever the tail is, that's the direction it's skewed. This is a symmetric one, so high in the middle. And then this is a positively or right skewed, so the tail's on the right side of the distribution. So questions you consider: is it skewed or symmetric, and does the distribution have a tail, and if so, at what end? So if we look at these 2 histograms, okay, this one is negatively skewed or skewed to the left because the tail is over here. Okay, so this is skewed left. So it's tail to the left. All right, so if we look at this one, this is skewed right or positively skewed. And it has a tail to the right. There's one other type of histogram that we need to look at, and that's a population pyramid. And so it's a double histogram. So we see we have 2 histograms here. And we've just rotated them 90 degrees so that the bins are along the central vertical axis and the frequencies are along the horizontal axis. And so it's an easy way to kind of compare 2 sets of data. So here we're looking at male and female in the United States in 1980. So the bars that are across from each other or across this central bin area kind of show us how the numbers of males and females compared. And so it's easy to draw conclusions and make comparisons that way.